Okay. Thanks everybody again for coming. What we're going to be presenting on this week is an introduction primarily to the new Seal-INX for transtibial liner and interface system. And we're also going to be introducing some of the additional flex feet that are now Unity compatible. So the Vari-Flex XC, the Balance J, and the Össur. All recent additions which really make the flex foot line fairly complete in terms of Unity compatibility. Okay, so just to review a little bit, what we have now in terms of the Unity system and the essential building blocks, we're using Seal-In technology, either using the Seal-In-V at a transtibial level. The Seal-In-V, if you remember, is our Seal-In liner that was originally designed with the Unity system that's vacuum compatible. It comes in 2 different seal heights, which makes it quite good to try to maximize surface area of the residual limb under suction or vacuum. If you haven't tried this system, also an extremely good interface to use for pure expulsion purposes. So sort of in a way in place of the X5 or the HSM, it would be a good system for you to try if you haven't gotten into that one yet. Very good hold in the socket, redundancy of sealing, and quite tolerant to volume changes as they happen in the socket. So it makes it a very good expulsion system as well. We also now have the Seal-INX available in transfemoral and transtibial designs. So fantastic that we finally have a modular sealing system where we can move that seal to any level that we'd like to maximize suction or vacuum along the length of the residual limb, and also to be able to move those seals away from sensitive areas or scarred areas and tissue on the limb itself. The socket connection we're using is the Unity valve system. It's a tri-function valve, and we're actually using the same valve at transtibial and transfemoral levels. The difference primarily being with the TT and TF kits is that the tubing is different. The transfemoral tubing is a longer tube that has a reinforced section around the knee break. It's reinforced with a snakeskin reinforcement. That's an electrical wiring reinforcement that prevents the tube from kinking or buckling and prevents abrasions and tears on the tube at the knee break. There's also some additional keepers to basically hold the tubing close to the prosthesis from the foot all the way up to the socket. And next we've got the flex feet. The flex feet, we've been building more and more Unity compatible feet over the last couple of years to where we now have a very complete series minus the talux foot. We have everything from the very low activity systems to the very, very high activity systems. So we have the Reflex series, the Reflex Shock and Rotate, the LP Rotate, the Vari-Flex, including the standard Vari-Flex and LP Vari-Flex. Now we have Vari-Flex XC, Proprio, and also the Proprio just itself, but also we have symbionic leg compatibility as well with this system. The Balance Foot, the Balance Foot J, and now the Össur as well. So we're really covering mobility and activity levels from low all the way up to high. And the vacuum pump mechanisms, we're either using a vacuum pump that's mounted with a support blade that works off of the heel deflection. And now what you'll see with the Vari-Flex XC, the Balance Foot, and Balance J and Össur, we also have pumps that we can use the forefoot deflection as well in those models. So we'll go through that today. And again, just for review, the primary benefits we've found with the Unity system is that it is a sleeveless design. There are very few elevated vacuum designs out there that allow the system to be sleeveless. So what does a sleeveless system offer? Well, basically, it's that increased knee flexion range, ease of knee flexion, greater knee flexion range, greater comfort, and therefore greater user acceptance in most cases. The problem, as many of you know, with the majority of elevated vacuum systems out there is that they are sleeve dependent, and sleeves tend to get punctures and tears and ruptures and things like that that compromise the suspension, and hence the advantages of even having an elevated vacuum system in the first place. This is a very lightweight and discrete system. All of the units only add a minimal amount of weight to the prosthesis on the order of 130 grams. And all of the pumps are housed within the foot shell. So we're not adding extra bulk or build height to the prosthesis or excessive weight. And it's all very discreet, housed within the foot shell. So we're not really changing or compromising any of the other benefits that the person would get from the active elements of the prosthesis, like the foot. It's a simple and efficient pumping mechanism. It's quick and easy to elevate the vacuum and to release those vacuum levels as well. We don't have any batteries to charge, like with the externally powered systems, and it's quiet when there's really no noise from motors or anything like that and pumps. It's an independent pump, so we're not dependent upon shock mechanisms or any other elements of the prosthesis to activate the pump. We're just using the natural dynamics of the foot as they are there, so deflection of the heel and deflection of the forefoot for pump activation. As with all elevated vacuum systems, this is going to help you both with volume stabilization and also potentially with wound healing and things like that. What you find with elevated vacuum users is that they tend to be using significantly less socks. Maybe not completely eliminating use of socks, but very much limiting it to half plies or single plies of socks that they may be using. So it really helps to optimize socket stability, proprioception and comfort throughout the day. And some users also find that they get assistance with chronic wounds that start to heal up, where the tissue becomes more supple and healed over time. There's clinical studies as well to back that up. It's increased in terms of reliability, and that has to do with the fact that we're not using a sleeve. So the fact that if you're going to minimize basically the incidence of leaks and punctures and tears associated with sleeve-dependent systems. And finally, as we mentioned before, we're integrating good quality performance FlexFit technology now that we can meet activity and impact level requirements for a very broad range of users out there. I wanted to put a plug-in for the upcoming AOPA Gazette. We wrote a clinical feature for the AOPA Gazette. The request actually was to compare and contrast contemporary prosthetic suspension choices. So we did that, and we basically, I think this article will help you with looking at the benefits of elevated vacuum over other contemporary systems. And we also have a complete series of scientific references with the article, 17 in total. This will also serve for you guys, I think, as a quick reference guide to choose between different families of suspension systems for particular clients. So whether you're looking at locking, or you're looking at purely sealant or cushion systems with sleeves, or elevated vacuum, you'll be able to compare and contrast benefits on these simple charts that are on there, outlining strengths and challenges. This may also, with the references, be potentially useful for you in applying for reimbursement support for the Unity system or other products. In terms of candidate selection for Unity, now we have compatibility for transtibial and transfemoral amputees anywhere from low to high impact levels. Again, weight limit is entirely based on the foot module that you choose and you're working with. And we have found that very conical limbs, whether at transtibial or transfemoral level, the shapes can be addressed in many cases with the use of a distal cup. So really, there are a minimal amount of contraindications for use for this system and the interfaces that go with it. The primary one would be very short residual limbs where you can't use the Seal-In-V or X, or when total contact cannot be maintained between the distal liner and limb. That would be true for any elevated vacuum system. You simply do not want to have any voids between the residual limb and the interface, or the interface and the socket. Okay, so voids are not friendly and can cause damage, significant damage to the limb. So make sure that total contact is present at all times. Or if you're expecting significant volume changes. As a general recommendation, we've recommended Unity primarily to people that are through the first year of amputation, perhaps looking at their next socket change and suspension system. So it's not for people where you're expecting really gross volumetric changes. I'd like to get into the first exciting bit today, is really looking at the new Seal-INX for transtibial. This is very new within the last month or so. We've just launched this, and hopefully this overview will give you some confidence to start using this system. This has been a much anticipated product. I think this is going to be very popular because this is something that clinicians have asked for since the advent of seal-in liners in 2003. When we came out with, I remember in the US with seal-ins, one of the first questions that people asked was, how can I get that seal to move? I'd like to move it to different heights to maximize suction. I'd like to get it away from certain sensitive parts of the limb and customize it for the individual. How can I do that? And there wasn't a way for us to do that at the time. Now we have that capability. So what the engineers have done, which is clever, I think, as well, is that they've used this modular seal in conjunction with profiles of the liner that match our cushion liner range. So this comes in a 3mm tapered profile or a 6mm uniform. Okay, that's quite nice. So if you were looking at even retrofitting cushion sockets, for example, you'd be able to do that with a very high success rate with this system. The seal placement, obviously, as we mentioned, is customized to the individual. And they've also made the seal, if you note, easier for folks to don and doff because they've added a little pull sock extension on the proximal part of the seal ring. So that makes it easier for folks that have issues with hand dexterity. It makes it easier for them to pull that seal up and get the placement correct before they get into the socket. So that's been quite nice for just vascular amputees and folks that do have hand dexterity problems. That's made things a lot easier. And then, you know, if seal-in suspension is not practical for your expulsion applications and so on, Seal-INX can actually be used, again, in just a pure cushion application with a suspension sleeve. So I think clinicians out there, you're going to find a tremendous amount of versatility and adaptability with this product for different people and circumstances and needs. It's a very good all-rounder in terms of cushion and seal-in design. In terms of the mechanics and how this works, I think it's fairly obvious how this works, but we'll just go through it. There are seal bands that are circumferentially placed from top to bottom on the liner, and those seal bands are made of silicone, and they penetrate the textile into the inner layer of silicone. So that's how we're actually able to create a seal between the seal ring and the liner and the wall of the socket. It's because of those seal bands that run from top to bottom on the unit. You'll note that there's a seal lip extension on the seal itself that prevents it, helps prevent it from buckling and folding. And there's radial seals that help the seal ring itself to seal redundantly against the socket wall. So if we lost a little bit of seal at one level, hopefully we would retain it at the other level. So this is similar to what we've used in the Seal-In V, and where we first used it was in the X5 concept. Another interesting addition to this system is a new fabric textile that's on the outside of this liner. We're calling this the anatomy conforming fabric, or the ACF. There is a patent pending on this technology. What's interesting about this textile is that it allows for an extreme amount of flexibility on the anterior surface of the liner, and it creates a stabilizing effect on the posterior aspect of the liner. So the liner only goes on in one way. It's rolled on the same way every time, and you have that posterior aspect of the textile behaving like the matrix and limiting any kind of longitudinal distraction of the liner, while the anterior surface is behaving much like what you've seen with the wave feature. It's creating that increased elasticity for easier knee flexion, more comfortable knee flexion and range. And what you see in that lower left diagram is that we actually have greater elasticity with that anterior section than what we have with even a dermo wave. So folks have found it extremely flexible and easy to bend their knee. At the same time, engineering's been paying special attention with the Seal-INX range in terms of working with better durability of textiles and also better adhesive strength. So what we know about these new textiles is that they have about twice the adhesion properties and several times the amount of abrasion resistance, and that's what you see here after cyclic testing of 50,000 cycles. On the ACF fabric, we start to get breakdown of the fabric versus 15,000 cycles with previous designs. So what we're very much hoping for is that folks get longer life out of these new liners with the Seal-INX range, and I would hope that if successful, this is something that we see implemented in other products with respect to interfaces in the future. In terms of usability testing, they did find that folks that had issues with hand dexterity, they were able to get these liners on and off much easier than our pre-existing seal-in liners. They had much higher satisfaction with the donning and doffing process, and it was faster for them to do overall. And again, with respect to retrofitting, they found that in retrofitting cushion liner type sockets, they had suspension obtained in 8 of 9 cases, and comfort the same or better in the previous 8 to 9 cases. So retrofitting, very positive with the cushion systems. We've also heard of very good success rates, relatively high hit rates in terms of retrofitting HSM and Seal-In-V and X5 seal-in designs. In terms of a performance summary, we know for the Seal-INX, the seal-in suspension can be achieved in a pure expulsion form if you want to use it for that. It's easier donning than with the Seal-INX5 and the Seal-In-V. It holds vacuum sufficiently for elevated vacuum purposes, so it's very good in terms of Unity compatibility. Fabric elongates easier over the anterior section of the liner with the ACF, so it's very flexible, easy to bend the knee, very comfortable that way. It's functionally equivalent or better to other seal-in solutions, and it can be used without the seal ring as a retrofit cushion liner systems from Össur. Again, also in conjunction with a suspension sleeve and expulsion valve if you wanted to use it in that capacity. Seal-INX dimensions, as I mentioned earlier, we have this in a 3mm tapered format or a 6mm uniform. And again, those follow the same profiles as our cushion liner systems. The seal bands are spaced about 20mm distally apart and 45mm as you move proximal on the liner. The rings themselves are 50mm tall, and then you have the extension, the sock extension that extends proximally from that. So that's what you see in the bottom diagram there. And the circumference or sizing of the ring is named at the very bottom of that ring circumference. I've thrown this reference chart in for you, and this is more for your future reference in terms of differentiating between different seal-in designs that we have and perhaps an optimal user for that particular seal-in liner. There really still is a place for products like the Seal-In-V and the Seal-INX5 in the range. And that's basically what this is outlining. So I hope this is helpful for you. If you're trying to decide what seal-in system is going to be best for a particular client, you could reference this chart, have a look through, and see if the information there helps you in making the decision. It outlines the different types of candidates and sort of strengths and weaknesses like volume, fluctuation capacity, ease of inverting and donning, speed of inverting and donning, compliance with shapes, pistoning and rotational control, and so on. So I'm not going to go through this in detail, but hold on to this and maybe print it out, and it's an additional reference for you to try to help you in deciding one seal-in liner compared to another. In terms of prescription considerations for Seal-INX, the only contraindication that we have here is basically very short residual limbs. When you get less than 10 centimeters or so, you're going to have trouble using this in conjunction with the seal ring. It doesn't mean that you couldn't use it as a cushion liner with a sleeve, for example. But when you get to those shorter limbs, the ring, it might be difficult just in terms of having enough length to use the ring itself. The the original target population for this product was looking at dyspascular amputees and folks that have compromised hand dexterity. They were really looking at something that would be easier for these folks to put on and take off. But we have found that this can be used for folks that are anywhere from less active to very active. So there's a wide range of application with this as long as you have enough limb length. In terms of liner sizing, this is going to be very familiar for you. It's a conventional ICEROSS method, so we're just measuring 4 centimeters from the distal end of the soft tissues, and we're choosing the size below if we're between sizes. So the same exact sizing for the liner that you'd use with basically your locking liner systems or your cushion liner systems. Same exact process. The only new thing that you need to learn for this is learning how to size the seal rings themselves. So as a basic rule of thumb, what you want to look for is a measurement on skin taken 6 centimeters at least below mid-patellar tendon. Why 6 centimeters? Because this gives you enough room to allow for that seal to sit below your socket trim lines. It's a pretty safe bet that it's going to seat properly. You could also take this measurement lower. If there's a longer limb that you're working with, you may want to take this lower. You may want to shift it up just a touch, but this is a general rule, 6 centimeters. Okay. The next thing that you want to do is you want to reference this chart and or the notes that I've placed below this chart, okay, for the seal ring size selection itself. So you have your measurement. This is probably the most important slide. If you wanted to print one of these slides out for future reference, this would be the one, okay? So you're measuring on skin for your seal ring circumference, then you're going to reference this chart. And the thing that's a little counterintuitive about this is that our seal ring sizing is going to go up size, okay? So I'll say it again. You're going to size up with the rings, not down. Most of our other seal-ins, you'd be looking at moving down a size with rings or with liner size to make it work. The Seal-INX for transfemoral works like that. The transfemoral one, you'd be sizing down a little bit to get the ring tension right. With the Seal-INX for TT, we're going to be upsizing all the time. So the general rule of thumb is that for a straight or a bulbous type shape, you're going to pick close to the straight or bulbous line, which is generally about 1 size up from your measurement. As you go to a conical shape, you need even larger sizing, okay? And it's typically about 2 sizes up, okay? So if you don't want to use the chart, just take into account the notes that I've placed below this as some general rules to follow. This chart's going to apply for 3 millimeter profile liners. 6 millimeters, you may even have to go another size up on those. Okay. So that ring selection is going to be different than what you've done before. And the other thing that's different is taking a look at the visual indicators for sizing once you've placed it over the liner and the limb. With HSMs, Seal-INVs, where we have an extension on that seal, we typically want to see that flush with the limb itself. With the Seal-INX for TT, we want to see a little bit of a gap. So it's that center picture that you want to be looking for optimal sizing. All right. You don't want that seal extension pressed up very tight against the inner wall of the ring. You're going to have more issues with losing seal and that seal not pressing out against the wall as you'd like. Okay, so just keep these 2 slides in mind, quite important. The chart and the notes below, and the photographs here for the seal ring sizing. We have 2 seal ring kits that you can buy. They are functional ring kits, so they're no different than the rings as you buy them in single packs. Okay, one has 5 rings that are in the most common sizes, and the other is a full ring kit of 10 rings. I would encourage you, if you think you're going to get into the system, to get a ring set and use the rings and replace as you use them. Because I have found with this, and also with the transfemoral version, that in most cases you're playing with at least 2 rings and trying to decide which is the best fit for the client. Okay. If you want to start out buying single rings, maybe buy 2, and whichever one doesn't work, you can send it back to us and we'll give you a credit for it. But if you really want to get into the system well, I think the fitting kits are really the way to go. Placement, what you want to avoid is extreme proximal placement of the seal. You want the business end of that seal well buried below your posterior socket trim lines. And again, that measurement of 6 centimeters below MPT is pretty reliable. It seats it pretty well below those posterior trim lines. Some photographs of sort of an optimal seal fitting and what you'd like it to look like, where that seal's pressed flat against the socket wall. You've got relatively even tension around it. There's no folding or buckling, and it's seated well below the posterior trim lines. Even in this case, we could potentially bring this seal up a little bit higher to where the very top of portion of that rubber ring is sitting just below the trim lines, okay? And that should be fine. We have found it very important with this system to make sure that the seal is well lubricated with the lubricant spray. Because you're dealing with a seal, and this is also true with the transfemoral version, that is not bonded to the liner, if it's not well lubricated when the socket's donned, the seal can migrate or fold or slip. So you really need to make sure that the seal itself is lubricated with the lubricant spray and that the socket wall is well lubricated at the same time. That's really, really important with this. Without that spray, you're going to have problems. Okay, so you need folks to be compliant with that. I wouldn't use any lotions or any other types of hand sanitizer and so on. We've found issues with those, that they have other ingredients that tend to soften up seals. So just stick with pure isopropyl alcohol and water. That's really what you need to do with this. In terms of your casting and modification, it's a very, very simple process actually if you just follow these simple rules. For casting, what you want to take are your circumferences on the limb from top to bottom, relatively speaking about 20 mil increments. You want to take at least an ml. I usually take an AP for reference as well. We want to take a relatively neutral cast that just has a slight bit of knee flexion included. We're going to be taking a relatively loose cast with elastic bandage first and then rigid over top, wrapping proximal to distal. The main point with casting is not to over tighten the cast and not to distort the shape. So you want to capture just a picture perfect resting position of that leg without any distortion of shape or any tightening of the cast. Distortion of the shape will create problems with vacuum, because vacuum will try to draw the shape of that leg out to its natural form, and if there's a shape that's different, it's going to be uncomfortable. Okay, and tightening the cast tends to elongate the model, and that also causes problems with comfort in your fit. So you just want to take a very simple cast. If you like to cast with vacuum, we haven't found that it's a problem. However, we haven't found that it helps you at all. So it's just a lot of extra work. Just taking this simple elastic plus rigid cast is really the best way to go. In terms of modifications, what you want to do is correct your ML dimension on the knee to the anatomical measure. You'll level out the seal area if you're working with a seal-in-V. Seal-in-Vs, you're going to take the cast and you have a seal impression in the cast that you need to take out. With the Seal-INX, you don't need to take the cast with the seal. It's without the seal, so in this case you wouldn't have a seal impression to take away with the Seal-INX. You're going to do a global 3 to 4% reduction from the patient measurements. I've typically used 4%. And for my initial fits, and I've had to increase reductions later up to 6% in some cases for the definitives. For those of you that maybe take tighter measurements, circumferential measurements, 4% might give you a tight fit, so you might go 3%. Okay, so that's why I've put 3 to 4 there. Everybody takes their circumferences with a little different tension, so just be aware of that. You're going to remove 6 millimeters distally, Why 6 millimeters? The simple reason is it seems to work. If you're gun shy about taking 6 millimeters off the distal end, try 3, and you can use your fit checks with pads, silicone pads around the distal end to see if that length is really appropriate. We've found that 6 millimeters works in terms of reduction for most cases, including residual limbs that are rather bony. And remember finally to attach the valve insert when you're pulling the check socket. The valve insert is the little plastic insert that comes with the valve that's threaded, and that backing is really important to have placed on the positive. You pull that for your check socket, you pull it before you pull your PETG inner for your definitive, and it allows that valve to thread into that dummy, and then you can seal the valve system from the inside of the socket with silicone and from the outside of the socket. That really gives you the best chance of not having a leak across the socket wall with the tri-function valve. Finally, this is a little bit of common sense, but it has come up a few times that the the socks, any kind of socks that you're using with the system, top or bottom, above and below seal, need to be placed outside the seal. Okay, so you don't want them tucked underneath the seal. Obviously, if you do that, you're going to lose vacuum and suction, and you're going to wick air through the system, so that won't work. You have to have those socks placed on the outside. We do encourage people to use socks, especially on your check socket fittings, to check for volume discrepancies. And generally, we do that placing socks above and below the seal to make sure that the volume is actually appropriate. By checking that ply, you can figure out how many percentage in terms of reductions you need to make before you do the definitive socket. And last, with the ICEROSS Seal-INX, that we have found again definitively that they retrofit cushion liner sockets quite well. If you're doing a vacuum application, just make sure that that socket was actually modified for a vacuum application, maybe not another. The Seal in HSM, Seal in X5, and V sockets have also been commonly retrofitted with the Seal-INX, so that's a great plus. Just remember on your definitive sockets when working with Unity or other elevated vacuum systems, whenever you're using elevated vacuum, lamination always leaks, so it's really important to use that PETG layer as the inner surface on the inside of the definitive socket. A lot of people are using 6 mil sheet for transtibs, and you pull that pulls really thin over the positive model and the dummy. You rough that up, and then you do your lamination on the outside of that. That's the best surface to prevent any kind of leaks. Okay. And always use plenty of lubricant spray with this Seal-INX system, as I mentioned before. That lack of lubricant can really cause that seal to move or fold or pull up when sliding into the socket. Now we'll get into a bit of the content that revolves around the pump systems and compatibility with additional flex feet. Recently, the Vari-Flex XC, the Balance J, and the Össur have all been made Unity compatible. The last webinar we had, I mentioned that the balance foot has also been Unity compatible. So I wanted to list all 4 of these feet out for you here because these pumps are also retrofittable to new model feet. So what that means is that with all 4 of these models, basically from June and July forward, if you're buying any of these feet, you'll be able to retrofit pumps in the future to the foot modules. That's not true of all Unity flex foot systems. Just these 4 models, we have the ability to retrofit pumps. So what's great about that is that we have a full range of lower impact, low activity feet from Balance, Balance J, and Össur. And we also have the Vari-Flex XC, which is ideal for your K3, K4 level users. Okay, so Balance for your K1, K2s, Balance J for your pure K2 level limited community ambulators, and Össur for your K2, K3s. the Vari-Flex XCs, all sizes, all categories will be fully Unity compatible by June 2015. So what that means is the older Vari-Flex XCs, they've had to change the pyramid design and made the distal end of it into a curved surface to be able to fit the Unity pumps and to have those pumps be secure, fitted against the pyramid there. So when you're looking for a Unity compatible Vari-Flex XC, you're going to look for that curved distal surface on the pyramid. That's going to indicate to you that that is a foot that you could retrofit a pump onto that if you wanted to in the future. And again, all sizes, all categories will have those for you by June 2015. What's nice about the Vari-Flex XC and what's different about this compared to some of the other systems is that we have some Unity feet that are using 4-foot deflection. So in the XC's case, when we deflect the 4-foot in mid-late stance, and we get deflection of the 4-foot and the upper C curve, the blade, the support blade on the pump, acts like a seesaw. So it pivots on the anterior portion of the foot module, and then we deflect that membrane, and that activates the pump. We're using the same barbs that you'd see on the other Unity systems for the intake and exhaust ports, and the same duckbill valves. And the whole pump assembly attaches to the pyramid with a single screw. Okay. In the Vari-Flex XC's case, there's not a particular torque setting on that. You're just adding, you're snugging up that bolt and adding some Loctite 243 to that on assembly to the pyramid. So I just added this slide from the IFU there just to show you how simple that assembly is, mounting that onto the pyramid if you wanted to retrofit this later onto a foot. You're just leaving a small amount of space between the tip of the support blade and the foot module before tightening up that bolt. And in the Vari-Flex XC's case, you're using the Spectre sock. You're fitting that between the support blade for the pump and the foot module itself. That's the only Unity foot that you do this on, is the Vari-Flex XC. Retrofitting the Unity for the balance foot, probably the simplest retrofit that you can do with a Unity pump. It's just a single clamp that fits over the pyramid attachment, and again, that's harnessing deflection of the 4-foot in mid-late stance to activate the pump. This is an ideal system for that household or very limited community ambulator who's seeking a very compliant and lightweight foot systems for purely low impact activities of daily living. Unity for Balance J and Össur. This pump will retrofit new models of the foot design in July of this year. So again, sort of same situation as Vari-Flex XC. Come July, all of the Balance J's and Össurs will be produced with this new pyramid configuration that will be Unity compatible for pumps. So if you were just purchasing one of these feet, and down the road you wanted to add a pump to it, you'll be able to do that with the new production models. Same as Vari-Flex XC, these pumps are going to activate with 4-foot deflection and mid-late stance. The Balance J we found really ideal for your pure K2 level ambulator that's looking for a compliant but supportive foot for single speed walking around the community. You get a nice full toe lever on that's nice and compliant with a very soft heel. The Össur is going to be better for folks that are that K2 level to low K3 level ambulator, looking for an active heel design, more active tibial progression, a bit more dynamic response on the foot. And retrofitting Össur and Balance J, again, you can see the difference pretty obviously between the existing pyramid design on the Össur and Balance J and what they're moving to with the Unity compatible pyramid. You can see that very large flat anterior surface on the new pyramids that will take the addition of the pump. So again, those new production models we're expecting July this year. Similar attachment that you see with Vari-Flex XC and support plate design. So we're using that same seesaw type action to activate the membrane. And the same types of intake and outlet ports, same types of barb and duckbill elements. And again, a single bolt that attaches the pump to the pyramid and the foot module. So very, very simple attachment, in this case with a 3 Newton-meter torque setting and using Loctite 243. In this case, for the balance J and the Össur, we're using the SpectraSock over the pump and the foot module. So we're not using it between the surfaces, we're using it over the entire foot and pump, as with the other Unity systems. Okay. Finally, in terms of warranty and maintenance, the standard flex foot warranty is going to apply, and trial periods to the feet themselves. The Unity pumps themselves have a 24-month warranty, the membrane about 12 months, and the SEAL-INX interface is 6 months. The Unity systems are all entirely field serviceable. You can tear them down from top to bottom, replace anything what you need. We do recommend that you do inspect the systems for the users on the order of 6 to 12 months regularly. We found in some cases that folks need to have the hose replaced and or duckbills and membranes at that 6 to 12 month period. So it's good to have those checked to make sure that the system's maintained well. And maintenance kits with spare parts are also available. In terms of other support materials we've got for Unity, we do offer a Unity TT training course and TF training course. They're available in Sydney or on-site at your facility. They're typically 2 days in length, and AOPA has awarded 18 CPD points for the course. So just contact Chris if you'd like to schedule a course. They are hands-on and basically building a prosthesis from start to finish with Unity, whether that's TT or TF level in those courses. We provide all the parts, and the user can take it away for a trial period following the course if they like it. We also have our TT order forms, TF order forms, as well as brochures for the Unity system that are quite comprehensive in terms of information, and the brochures are particularly useful perhaps in discussing and educating your clients about the Unity system. There's also a nice fabrication animation that's on the website that walks you through all the details in terms of making the system from start to finish and assembling the system. I'd like to thank everybody for joining the session today. For everybody and quite informative, and we hope you're excited about the Seal-INX and some of the new Unity additions with the FlexFoot range. So please pass your questions over via the chat box or raise your hand, and we'll answer as many as we can here. So we'll stick around for another 10 or 15 minutes, depending on how many questions come up. Thanks again to everybody for attending. So one question's come up in terms of maintenance of the membrane itself. It's one of the vital elements of the pump. What we've been finding is that the membranes, they just kind of basically loosen up. It's a very tough membrane. It's made of a solid piece of rubber that basically the fitting, it is deflected over and over and over again with each step. And we have found on the order of a year or so that they do loosen up and they probably need to be replaced. So somewhere between that 6 and 12 months, it's good to have the person that's fit with Unity just to have them come in and check and make sure everything's still working properly. I think you'll probably find it's pretty obvious people that are more active walkers or higher impact users. They're probably the ones that you need to keep a closer eye on than some of your low impact users. So you know that that maintenance interval will probably vary from person to person, but I think, from my opinion, it's good to look at that somewhere between 6 and 12 months.